So these are going to be the notes for chapter 13, which is transferring us from thinking about things in terms of randomness and simulations to actual probability of things. Okay? So the probability of something, it is the long run relative frequency. Okay? So in the end, it's what should happen and the frequency that something does happen. Okay? When you have probability, each attempt is called a trial, and from each trial, you have an outcome. So if I flip a coin, that is an attempt, so I have one trial, and my outcome is whether I get heads or tails. Okay. When you think about the word event, okay, an event is all the combined outcomes. So if I flip a coin 3 times, then I had 3 different trials, so I had 3 different outcomes. Okay. So the notation you have is going to be the probability of an event, and a lot of times you're going to see the probability of maybe event A happening, and that is just the number of times that A occurred over the total number of trials. Okay. A lot of times our probabilities, we're going to write them as percents, and in our percents we have to change them to decimals. Okay. So we have a couple different types of probability. There's theoretical, which is kind of what should happen based on math knowledge. So an example is, I know that half the time I flip a coin I should get heads, and half the time I should get tails. That doesn't always happen. And so when you actually find out, and maybe 2 out of 5 times I got heads, that is called experimental probability, because that's what was specific to that experiment you did. Okay? Theoretical is the what it should happen. Like a deck of cards, I should have a 1/4 chance of pulling a diamond from a deck of cards. Okay? Another word you need to be familiar with is independent. Things are independent if the outcome of one trial does not affect the outcome of another. Okay. So an example would be if I'm pulling marbles out of a bag to see the color. It's independent if I put the marble back in the bag. But if I hold on that marble and give it to somebody else, then my probability is going to change because there's not as many marbles in the bag. Okay. All right, so the law of large numbers. What this pretty much says is the more you do something, the more accurate it's going to be, and it's going to eventually get to the true proportion or the true probability that an event will happen. So you repeat a random process, and the proportion it happens, that is the probability. So if I ask you to flip a coin 3 times, that'll be probability. If I ask you to flip a coin 3 times, then obviously it can't be even. So how about 8 times? If I ask you to flip a coin 8 times, you may get 5 heads and 3 tails. But if I ask you to do 1,000 times, it's going to be closer to 50%. Okay. One thing that we need to make sure is something called the law of averages. The law of averages is that famous thing of, oh man, I've hit a red light, every red light for 10 times. So I'm due to hit a green light. Or saying that someone's on fire when they're shooting baskets, or that they're kicking field goals, because you think that they've made so many in a row that they're on fire and their probability is going to go up. Really, that doesn't happen. You're not due to win something. You're not on fire. And so things don't actually kind of relate to each other when you think that you're on a hot streak. Okay? So you can't be due, even though it feels like it and you feel like you're doing better, statistically speaking, it doesn't actually happen. So you can't be due to get or make something. Okay? All right, so there's 5 formal rules of probability that we're going to focus on today. The first one is that probability is a percent, and the biggest percent you can have is 100%. So the probability of an event occurring is between 0 and 1. It's very rare that you get 100%. You could have 100%, but then you wouldn't really do the probability of it because that's not interesting to know that something's going to happen all the time. Okay. The next thing we need to know is that all possible outcomes for probability have to equal 100, which is 1 or 100%, depending on how you're writing it. Okay. So the next one is the complement rule. I'm going to underline it because it's an actual rule. This is just saying that the complement is what you don't want. So if I'm saying how many times I flip a head, the complement is how many times I don't flip heads. And so I do versus don't, those should add up to 100. It's the set of the outcomes. Not in what I'm looking at, not in the event you're looking at.
Students, there's T-shirts for sale for the past.
Okay, so the rule for probability is the probability event is equal to 1 minus the probability of its complement. That little c means the complement. I don't think you're going to see that notation a ton, but I want you to be familiar with it. Okay, so again, you have what you want and what you don't want. Both of those together should equal 100%. So to find the complement, it's what you don't want. Okay. All right, so the addition rule. The addition rule only works if things are disjoint, which also means they're mutually exclusive. These are things that can't overlap, okay? They have to happen at different times. You can't be a part of both groups. The addition rule works for OR problems. And when you have an OR, it's called addition for a reason. You're going to add the probabilities. Okay. So this is the notation for it. It's a union of the two, meaning I can have anywhere where one is or anywhere where another is. And so the probability of A or B is actually the same as the probability of A plus the probability of B. Okay? So for OR, you're going to add. And again, the only way you can use this basic rule here is if they are mutually exclusive, which means they don't happen at the same time. Okay? The last rule that we have is the multiplication rule. This multiplication rule I'm going to show you today only works if events are independent of each other. Oh, I can't spell. Independent events. If they're dependent on each other, that's another formula that we'll be getting to in the next chapter. Okay? So, multiplication rule is and. I want this to happen and this to happen. So I'm going to multiply my probabilities. Okay. Okay, so take a second now to copy this down, press pause, and then once you're back, I will go over it. Okay, so what we're looking for is the probability of cars not made in the U.S. So there's a couple ways you could do this. Pretty much I don't want any car in the U.S., so I could do the probability of German or Japan or other. Or I could do 1 minus the probability of U.S. because it's not what I want. I'm looking for the complement. And so both of these, if 40% of cars are made in the U.S., 60% are not. And that's just a basic probability problem. We're going to get into the ones that are harder. Okay, so what is the probability of cars made in Japan? or Germany. I forgot to write that. So it's one or the other. And when you see this big word or, remember or means to add. I'm looking at one card and it's either made in Japan or Germany. So it's the probability of Japan or Germany, which is going to add. And so it's going to be 30 plus 10, which is 40%. So if I look at a car, 40% of them are made in one or the other. All right? The second one, I'm starting to look at something in order. I see two cars. And so when you do that, I like to write my two blanks because it's just going to help you, because sometimes eventually you're going to have 4 and 5 blanks, and this method can really help you visualize it. So I have two cars that are Japanese. So I have a Japanese and a Japanese. I want this to happen and this to happen. So remember, and is multiply. So Japanese is 30%. So it's 30% times 30%, which is 0.3 times 0.3. So 9% of the time, I will have two cars, and they'll both be made in Japan. All right, so I'm going to show the next 3 problems. We're going to use the same percents. So go ahead and copy those down, and then come back so we can go over it. Okay, so the probability that 3 cars are not German. So I got 3 cars, not German, not German, not German. Well, German is only 10%, so I have 90%, so 0.90, 0.90, and 0.90. Now, if I added these up, it would be too high. It'd go to 270%. So for this, because it's multiple cars, you're going to multiply, because I want this to happen, and this to happen, and this to happen. So you multiply those numbers, and I get 72.9%. All right, the next one's probably one of the trickier ones you're going to have, and it's this word at least. At least is a hint for you to do the complement. So it's going to be 1 minus what I don't want raised to the third, because there's 3 cars. So I'm looking for U.S.-made cars, so what I don't want is not U.S. Okay? Well, U.S. is 40%, so not U.S. is 60%, so it's going to be 1 minus 60% to the third, and again, it's to the third because it's 3 cars. And so when you plug that in the calculator, it's 78.4%. All right, last one. So I see 4 cars, and the first time I see a Japanese car is on the 4th car. Okay? So I'm going to make 4 blanks. So this is a Japanese, this is the not. So the 4th car is Japanese, so the 4th car is 30%. The rest are not, so it's 70%. Well, I want this, and this, and this, and this. So since I want all of them, I'm multiplying them. And when you multiply those, it's 10.3%. So remember, if you're looking for one car or one item, it's probably an or. And so you add. If it's talking about multiple things happening, then it's multiplying. So it's a multiplication problem, and it's an and problem.